So I'm Gert. I'm a software engineer at a company called Chromatic. I am from the Netherlands, but Chromatic is an American company. We all work remotely. And Chromatic is mostly known for being the driving force behind Storybook, which is an open source project in the front-end ecosystem. So if you happen to know any Storybook users in here, a few, great. So I got some Storybook stickers, by the way. So come grab them if you want. Also Chromatic stickers, but if you like those. Any Chromatic user by any chance? It's a GraphQL thing. So anyway, my Twitter is @Hannibal, so follow me. Without further ado, let's get started. So let me first introduce Storybook for a bit for those who don't know what it is. So these days, modern user interfaces are built or actually assembled from components, right? People don't go reinvent the wheel each time they build a new screen. They build buttons, they build input fields and forms and all that sort of thing, and then they reuse that all over the place in their web app or application that they're building. This brings efficiency and speed and quality and makes maintenance easier. So, and there comes in Storybook. Storybook is a tool, a workbench for building those UI components in isolation. What does that mean? It means that you can focus on that particular UI component that you're building right now, and you don't actually have to spin up an entire web app or like a server or whatever on your local machine or anywhere in the cloud to do that. So that's great. Actually, it's great for designers as well. They don't even need like the entire repository checked out. They can just check out the Storybook and be working on their UI stuff that they need. It's also a way to catalog all of the UI components that you have in your application and then document your entire component library for other developers in your company or even in the world to use in their applications. And finally, it's a way to share the UI part of your work with stakeholders. So I'm not here to talk about Storybook, but I wanted to introduce it anyway. So a little bit on stories. Where does it come from? Well, you can think of stories as things like states, various states in your application, loading, disabled, in progress, various edge cases. You have like a button with a very long text. How does it deal with that? Or very big images that might be loaded. Or are you signed in right now or not? Is there like an A/B test or a color preference? All that sort of thing. So it gets big very quickly, especially since you have countless combinations, right? If you're a UI developer, you need to take all of the variations that you have into account. And it's pretty much impossible without a tool like Storybook to make that easier for you. So on top of Storybook, we built a tool in the cloud, a cloud service called Chromatic. And Chromatic is basically the collaboration part of Storybook, if you will. Storybook is a tool that you download on your local machine, you run it locally, it's on local hosts, it's for an individual developer. Well, Chromatic is something for an entire team, for an entire company to use. You publish your Storybook to Chromatic, and then Chromatic goes and takes screenshots of all of those components and does that each time you push your code to GitHub, for example. And then it retakes all of those screenshots and compares them pixel by pixel, and then it gives you like a left and right comparison, what changed exactly visually in the pull request that you just opened. Right? So you get a visual review for your pull requests. And then stakeholders and designers and product managers can go and place comments, like put comments and approve and decline the changes that you made. Okay. So that's basically what we do in a nutshell. But for all intents and purposes of this talk, you can think of it like this. You build a Storybook on your local machine, you push it to the Chromatic CDN, and that's where this story starts. So we started with some new, looking for some new horizons. We had several projects lined up that we wanted to realize, but they relied on being able to extract information that we had as Chromatic, but make it available publicly, or at least to these particular projects. So the first one was that we were developing a plugin for Figma. Figma is a tool for designers to design front ends, right? And what we wanted to be able to build is a plugin for Figma that allows you to link a layer in your design tool to a live component as published on Chromatic. So that gives the designer the ability to just click a layer, and the live component that you can actually interact with shows up in a panel in Figma. So we needed a way to give those designers access to the actual live components as published on Chromatic. Well, this is a little bit tricky because Figma is actually a desktop app, or it can be a desktop app. You can also load it in your browser, but either way, it does not have access to the authentication cookie that we have for Chromatic, chromatic.com. And also Figma files, they're shared across collaborators, right? Figma is a collaborative platform in the cloud as well, like Chromatic. But the client storage API that Figma offers for plugin authors is not shared across users. It's kind of like local storage in your browser. What we do is we link a component in Figma to a story in your storybook that you publish in Chromatic. So that relationship needs to be stored somewhere, right? And well, we happen to have a cloud platform up and running already called Chromatic. So that was a natural place to store that relationship, right? So we're storing it in a cloud at Chromatic, and additionally, the storybooks that people publish to us, they're very often private, right? So they're behind authentication, and we need to do the access control. Another project that we were working on is something we call the Component Encyclopedia. The Component Encyclopedia is a public thing. It's a part of the Storybook website. You go to storybook.js.org/showcase, and essentially what it is, well, it's a showcase of all the storybooks that other companies around the world and the teams around the world have built and publicly shared. And we are indexing those publicly shared storybooks in one place. So you can go to this Component Encyclopedia, key in button into that search field, and all the variations of buttons show up from like the Audi design system, or Visual Studio Code design system, or the Shopify design system. All these companies around the world, like Microsoft design system, all these companies are building design systems these days and sharing them publicly, so you can actually use a button from Microsoft if you want. You can even oftentimes grab the source code of that button component if you want to use in your own project. So this was a slightly different kind of integration, API integration that we need to build, because in this case we are dealing with public data, but there is no user actually signing in anywhere, right? But we do want the component Encyclopedia to be securely connected to our API, if you will. So what does it do is, what we needed to do is get hold of the story metadata, like the name of the component and the name of the story, and also screenshots, obviously. Chromatic happens to already take those screenshots for the visual displaying that you saw. So we're actually taking the thumbnails of those components and throwing them up on the website on storybook.js.org. But we do, of course, want to basically protect ourselves from people abusing our API. So even the component Encyclopedia has some rate limiting applied to its thing, just in case it screws up somehow. Which brings us to authentication, which is actually the first thing that popped up because of those two particular use cases. Anyone has any idea where this is going? Any terms? Yeah.
I'm guessing you're going to do a JWT proxy. So you end up passing a cookie along, so it's stateless, but then reuse it.
Well, JWT is definitely in the mix here. The term I was looking for is OAuth, right? Which JWT is obviously used in part of. So what we needed to do is become an OAuth provider, right? We're already an OAuth client in the sense that when you sign into Chromatic.com, you're actually signing in through GitHub or through Bitbucket or GitLab, which are also OAuth providers. But now we had to become one ourselves. So how this works is that anyone who wants to start a connection with our API, they need to register as a client with us. And because we had already these two different types of application, one where a user needs to sign, like it needs to connect and approve, like you can see on the right-hand side. But the component Encyclopedia has no user involvement. So there's multiple authentication flows that you can do with OAuth, and I'll get into that. But in the end, the goal is to get your JWT, basically a token that says, oh, hey, you're authenticated, you can now make requests to our API, and by the way, these are some scopes that you have access to. And one of the authentication flows also unlocks the option to act on behalf of a user, which is what you see on the right-hand side here for Figma. If you want to connect Chromatic to Figma, you need to approve that. We read the profile information, and Figma is able to manage its own metadata. Well, do you allow? Sure. All right. So, but there was something slightly more complicated here. The typical flow for OAuth is, well, you click on a button, it opens a new browser tab, you say approve, and then it closes that browser tab and redirects back to, or it actually redirects back and then closes the browser tab, and then it will send your connect. Well, that's nice, but we don't actually have a browser here because Figma is a desktop app. So there's actually this alternative flow called device code grant that you can implement with OAuth, which is handy when you don't have access to the auth cookie. And typically it's used for what they call input-constrained devices, with the typical example being a smart TV, right? You have a smart TV, you want to link it to your Google account, and it says, oh, hey, please, here's a 6-digit number, please key it in into your mobile phone or your wherever, right? But this workflow is also very useful for desktop apps. So that's what we ended up implementing for Figma. So even if you use Figma on a completely different machine, you can still link it up to the Chromatic, your Chromatic accounts where you log in on another browser. The other one for the component Encyclopedia is using the client credentials grant, which is basically a server-to-server connection. And it's super simple. You have a shared secret, so when the client is registered, you generate a random key and share that with whoever is registering that client, and they put it somewhere in like a secret, like a variable or whatever, like an environment variable or something like that, and then you never show it again, basically. And then anytime that client wants to deal with the API, they send that super key and they get back a JWT. So, implementation of this, we build everything on JavaScript or TypeScript actually at Chromatic. So that means the front end, but also our back end is built in TypeScript, and we use Node and Express for that. So I went looking for suitable NPM packages. That's what every developer in the JavaScript ecosystem does, is can I pull something off the shelf, basically. So there are a few that popped up, most of which were created 8 years ago and have not been maintained since 7 years ago. With one notable exception, I think it's called Node OIDC something, which I tried. There's one package that seems to be actively maintained. However, it was so hard to configure. Like the default authorization code grant, like which is the default flow for OAuth, sure, easy peasy, right? Copy and paste and it works. I believe that it will work, but I needed the device code grant and the other one, which were super hard to set up. I mean, I could figure it out, and eventually I think I had a proof of concept that kind of worked. But really, I have zero confidence that I configured it properly to be secure and that nobody will be able to hack it. So what I ended up doing is just read freaking RFCs for OAuth and then implement it from scratch. So there's like 3 or 4 RFCs that are read. And really, it's not that complicated. So here on the right-hand side, it's basically just a bunch of if statements that you need to go through, and they're all defined, all described in the RFC that you need to do. And then there's a little bit of a complication where you need to do PKCE verification, which is like a best practice for additional security. But even that, it's basically doing some base64 encoding on like some key concatenated with some other key, and then you compare 2 strings. It's not that hard. So I have way more confidence in this thing that I wrote from scratch in like 300 lines of code with 500 lines of unit tests than any library that had like 1,000 lines of code or more. Right? So that's what I ended up with the authentication part. Next comes another interesting thing that, of course, with any API, you need to think about how am I going to design this API? What methods or like entities are going to be there? Schema design, right? For this, I just did a bunch of research. We already had a purpose-built GraphQL API, so choosing a GraphQL was for a great no-brainer for us because our web app and our backend are already connected using GraphQL. However, it's one of those APIs that just grow over time, and you add new stuff, and eventually it's a huge mess, and there's like 3 different ways that pagination is getting done, filtering, right? And okay, let's do it properly this time and start with a clean slate. So what I did is like, okay, we have this web app API and we have a public API now. By the way, at the moment, they're still in the same code base, the same server. Eventually, I want to move the public API to a separate server or service or whatever you want to call that thing. Somehow that I can like make sure that they're not handled by the same server in the cloud. So I started to read up on best practices, and I found this excellent book. I can recommend it to anyone. I bought this book, and basically what follows in the next couple of slides is basically a summary of all the stuff that's in the book. So if you want to get the full Monty on it, that one. Right? So, and then I went to compile, like I read the book, and there's like various all kinds of things, and we did some research on the internet as well, of course. Already knew a bunch of stuff as well. And compile a set of guidelines so that I have some rules to follow for myself, plus my colleagues and everyone else who comes along and builds on top of it later has some guidelines to do this right. So here's a summary of that. Fields first, right? Simple things like all entities should have a unique ID, and for convenience sake, we also prefix them with their current type name. So that looks something like project and then some random MongoDB ID, object ID. The reason for that project prefix is that if you then go and use the root node field on query, you throw in that project thing ID, and it's able to fetch it, and it knows which collection to look for, right? Basically, which table you want to query, right? I mean, we could look it up without that thing, but it would be less efficient. And then another little thing is when you're evolving an API, you quickly get like a whole bunch of related fields on a like you have like say an account object, and you have like a repository name, a repository ID, and a repository I don't know what. Eventually you have a whole bunch of things, they're all about the repository. Maybe you should just create an object called repository and have a name and ID and such and such on it, right? The primitive, don't have a whole bunch of primitive fields, create an object scaler, which scales much nicer. And gives you the ability to type it properly, and etc., etc. Nullability, of course, always a topic in any program, most programming languages. But in GraphQL, fields and arguments are both nullable by default, which is annoying because it's more complex, right? You get more complexity to deal with the null all the time. And if you design a proper schema, any API really, please avoid null if you can, like nullability. Of course, if there's like a reason why it could be null, then by all means make it nullable. But we really would like to get some guarantees, and especially about inputs. Like if you have a mutation that takes arguments, by all means make those arguments non-nullable. With some exceptions. So async fields, anything that like you need to go out to a database to fetch that record, right? That should be nullable because the database connection could fail. And if you don't make it nullable and it fails, that means that the parent of that field, that contains that field itself will become null. So you get nothing, right? The parent will that basically bubbles up to the top parent, and that might even bubble up even further if that thing is not null. Restricted fields, aka something that requires particular permissions, should also be nullable because, right, maybe I happen to have a role that does not have particular permissions, then that thing should also be null. And for the sake of extensibility, when you already have like a field that takes arguments, if you add another argument, then either make that additional argument null or create a new field altogether, because otherwise you're introducing a breaking change. Errors. We kind of read there's kind of 4 types of errors in a GraphQL system. The first obvious one is user error. And the user error is basically something that relates to a business rule in your application. So, for example, here's the example. I'm registering a new user account, but the username is already taken, right? That's a business rule. The username must be unique. Or the password needs a particular length, right? So in that sort of case, you should make your error part of the design of your API. So you should actually have a particular type for it and then return that type. And a convenient way to do that is to use a union type for the various errors that can occur, and a payload type that contains either the user that was created or a list of user errors. There might be multiple errors at the same time. So if you have a big form, there might be multiple fields that become red, right? Client errors are, and both client errors and server errors are actually errors that you can't really design for. A client error is where the client implementing GraphQL is doing something that your thing does not allow, like a type error, or maybe it's hitting a rate limit, or doing some other thing that's illegal. That's basically up to the client, the implementer of the client to fix. So just throw an error, which becomes a regular GraphQL error. And the same thing goes for a server. So say your server is unable to connect to your database, then that's something that you can't really design for. It just throw an error. And then finally, for authorization errors, basically saying this thing, you're not allowed to see it, return null. And you could return like a particular not authorized error, but that means that you are actually revealing the fact that the thing exists, right? So better just return null and then pretend that it doesn't exist, because that user is not supposed to know that it exists. Mutations. So using a unique input type. A unique type, the benefit of that, so meaning that the the argument to the mutation is typed, which is easier to extend because if it's an object, you can like say, okay, I expect additional arguments or additional properties on the input. But adding like a fifth or sixth argument to like a list of arguments, that's super unwieldy and basically hard to manage. We have the same thing for payload with like as with the error, you can do the same thing with the success type. A payload that returns a success type and potentially user errors if there are any. And then this is kind of maybe nitty-gritty or detailed, but if you are thinking about this sort of thing, course insertions versus final updates. So say you are a shopper and you want to add stuff to your cart, you can say, oh, here's my entire shopping cart, I'm creating a new one. But when I want to update, I just want to increment one particular item, so you have a smaller update mutation. All right, authorization. How am I doing on time? Let me check that first. Pretty good. So what we do is leverage the OAuth system, of course. And in OAuth, you have this concept of scopes. And scopes is basically a list of strings, or actually it's a single string with space separated scopes. But you could, and you can invent anything you like do whatever you want. But what we settled on is something like your domain, the business domain type on the left-hand side, and then either read or write. And there are some more complex options there as well. But mostly read and write for the scope that you can. So in this case, you could read the account and write to the project. And write implicitly means also read. And then you map those scopes to GraphQL field types. So the account, capital A type, or a project, capital A type. So the kind of the naive thing, that's the thing that I actually started out with, is to map scopes to individual fields, right? So say I have a project field, and then I say only if you have a project read and write scope, then you can query for that field. But the downside of that is that if you add a new field that also somehow returns a project, then you need to think about the fact that you need to deal with authentication and actually filter out that particular field as well. Or if you do like an allow list approach, you need to allow that particular field if you have that scope. But if you do it on the return type, if you will, of that field, any place where you return a project or an account type, that scope limitation is going to get applied. Of course, that does also mean that you need to be very wary that for example, any mutation that you do, say you mute a project, and that mutation should return a project, and not a Boolean. And of course, additionally to all the stuff that you do, is use the regular auth checks, like can this user even see this resource? Are they a member of this project? And a great library that we actually ended up using is GraphQL Shield, which has a pretty solid mechanism to do this kind of authentication check. All right, pagination. I think probably everyone is using the relay specification, like connection model. Anyone doing any other type of pagination? We did. I know. We had like some poor man's implementation of our own pagination thing. Well, just don't do it. There's a de facto best practice these days, and it is cursor-based pagination using the relay connection model. But first off, let's talk about arrays or lists in GraphQL in the first place. Especially if you're dealing with a public API that that exposes user-generated content, if you will, like uploaded Storybook, people that happen to upload the Storybook to us, that is user-generated content. We have no idea how many stories are going to be in that Storybook. There might be thousands, right? Just avoid any unbounded lists. So, right, a list that can go to infinite length, basically. So only allow an array type if you know if the things like hard-coded, so the months of the year, right? Or if it's always going to be small. We have one particular example where we plot everything against a Git graph, and we know for a fact that a Git commit can only have at most 2 parents, right? It's just the nature of the DAG. So that is another example of where, okay, we know certain is going to be small, so we can use a regular array. But for everything else, use a connection model, and it looks like the thing on the right-hand side. You say, okay, give me my friends. I just want the first to anything after this ID. That's cursor-based pagination. That's random string. That's the cursor, and that gives you then a list of edges. But we actually extended this little schema to also just give me a list of an array of nodes, because dealing with edges, that can be convenient if you just want the first 3 and are never going to ask for the next page. If you are going to ask for the next page, you will need to get, probably you will need to get the edges and the cursor off of it, or use the end cursor in the page. And one additional thing that when I started out implementing this, the logic for pagination quickly dribbled through from the resolver layer into our model layer onto like the database side of the whole application, and that's just adding complexity throughout the entire stack. So I ended up like doing some refactoring to just make sure that the whole pagination logic only existed in the resolver layer for GraphQL and did not trickle down into our domain models. Right, so for any public API, you probably want to think about performance. So a couple things for performance. I'm no expert, by the way, by any means on this. I just did my research and figured things out as I go. But one thing that we were already doing is using the data loader pattern. That's kind of a no-brainer. Probably who's using the data loader pattern? The most? Oh, not that many actually. So the previous speaker already mentioned the N+1 problem. Well, the data loader pattern is one way to deal with that problem. And essentially, it adds batching to your queries. So, say you have a pretty complex GraphQL query that asks for users and then their friends, right? But some users have the same friends. So that means that you end up requesting the same friend information multiple times and going to the database to request the exact same user ID multiple times. So wouldn't it be convenient if you could just basically only fetch it once and then return it for all of those instances of that particular user? So that's where the data loader pattern comes in. And then you need to think about rate limiting. But the typical way to do rate limiting in like a REST API is just to say, oh, you can do this many HTTP requests to our API in an hour, right? Maybe you can do 5,000 requests per hour. And then when you run out, and that's it. So in GraphQL, that doesn't really work because a query can be infinitely complex. You can request the entire system, like the entire, basically everything in the entire graph if you want in one query. Which means that you need that the system will be doing a ton of requests to the database, and obviously it will be very slow. And if you do 5,000 of those, it quickly boggles down your system. So the trick here is to calculate the complexity of the query that is going to be executed based on some rules. And there's libraries out there that do that for you. So I did not invent any of that. But basically, what you end up doing is calculate a complexity score, and then you have a budget for your complexity. And that is how you do referencing. And there is a trick for caching that I found fascinating. I have not yet implemented this, but one downside of GraphQL that's often mentioned is that because GraphQL typically works over HTTP posts, you don't get any HTTP caching, right? So nice thing in browser is that HTTP GET is cached by default, as if you provide proper headers. But you don't get that with GraphQL, unless, of course, you run GraphQL over GET, which is totally possible, by the way. The downside, of course, one problem that happens is that if you have a big enough query, it doesn't fit in the request body, right? You end up hitting the limits for the request body because the URL can only contain so many characters. So the solution there is to create persistent queries. Basically, it's kind of like pre-registering a query. So you post a query to this GraphQL server, it will store it somewhere and give you an ID back, and then you do a HTTP GET query to the server, giving it that ID. And that there's a way around it, and you get caching using HTTP GET. So you just need to pre-register your queries. There's actually, it's mentioned in the book, I have not really looked into it. Another next level step of this is to actually pre-compile queries, meaning that it doesn't have to parse the query, the GraphQL query again. It already has done that, kept it in memory and whatnot, maybe even, I don't know, heat up the database, whatever. Thanks for listening.